Improved levels of performance, safety, and comfort. Railway systems made in Germany have proved their worth all over the world for many years. Innovative railway technology has a long tradition in Germany. Here, trains were traveling at 230 kilometers an hour over 70 years ago. Even then, Hermann Kemper already had a vision of a railway operating without the use of wheels. In 1934, the certified engineer is granted a basic patent on the principle of a suspension railway. That his idea would actually work could, at that time, only be demonstrated experimentally. The high-performance electronic equipment necessary for the development of a magnetic induction suspension railway was not to be available for a good many years. Where advanced technologies are concerned, decades often elapse between discovery of ideas in principle and the technical possibility of their application. Things were no different for the maglev technology than for many other developments in air and space travel, or in computer and telecommunications technology. And as in any advanced technology, maglev development is continuing. Starting point for the maglev in Germany was a study commissioned in 1969 by the Federal Ministry of Transport into high-performance, high-speed railways. This encouraged consideration of totally new technologies, along with improvements in the performance of and modernization of wheel-on-rail technology to help solve traffic problems. Within 2 years, the first passenger-carrying proving vehicle is hovering along a test track about 700 meters long in Ottobrunn near Munich in a demonstration for former Minister of Transport Georg Leber. A range of different development possibilities are still being pursued. In 1972, a project group in Erlangen starts on the development of electrodynamic hovering, actuated by superconductive coils, operating on the principle of magnetic repulsion. The Erlangen proving vehicle does its first trial circuits on the test track later that same year. And 1 year later, the test vehicle Transrapid 04 is in action. On a test track mounted on pylons in Munich's Allach district, it later reaches speeds of over 250 kilometers an hour. The intention is now clear. The speed of a new non-contact railway system should substantially exceed that which the wheel-on-rail system can achieve economically and in an environmentally acceptable manner. With a component measuring testing unit, the Comet, proof is furnished in 1974. Accelerated by a sled fired by hot water rockets, the unmanned Comet hovers, lifted and driven electromagnetically, eventually reaching 401 kilometers an hour. These trials provide important information. At the same time, development of the long stator magnet driving technology is started. In this concept, an alternative to the line being followed at the time, the primary motive force is not installed in the vehicle, but in the actual track. The first passenger-carrying experimental vehicle with long stator drive and electromagnetic suspension system is commissioned in Kassel in 1976. After examination of a number of different developments, the federal government reaches a decision at the end of 1977. Since then, development in Germany has concentrated exclusively on the electromagnetic induction suspension system with long stator drive. Right from the start, economic viability has been of major importance. Rational construction and assembly procedures are developed to reduce the costs of modules and components of the new railway system as far as possible. less than 2 years later, they justify themselves on first application of the maglev principle. During IVA 1979, the International Traffic Exhibition in Hamburg, Transrapid 05 carries more than 50,000 passengers, including the then Federal President Walter Scheel. Operating a scheduled service, the first Transrapid to be licensed for passenger carrying hovers over the 900-meter-long track from Heiligengeistfeld to the exhibition ground. After the exhibition, the installation is re-erected and operated in Kassel in order to continue developing the system. The success of the Hamburg operation demonstrates that in order to test the maglev system as far as possible under service conditions in continuous operation and to develop it to production readiness, a test track is essential. In 1980, construction of the Transrapid Emsland test track commences. The TVE, which has a total length of 31.5 kilometers, including 2 loops, is constructed in 2 sections. Transrapid 06 goes into operation on a first section in 1983. After completion of the first section of the test track, Transrapid 06, which is constructed as a 2-section unit and designed for a maximum speed of 400 kilometers an hour, starts on a series of trials in continuous operation. In constructing the second section, the reinforced concrete and steel track supports have the driving component installations specified by computer. This guarantees an optimal level of accuracy. The second section of the test track is completed in 1987, and the test facility thus becomes the largest of its kind in the world and a magnet for visitors who want to experience a trip with Transrapid 06. These include Federal President at the time, Richard von Weizsäcker, who afterwards says, "Traveling in the Transrapid is more pleasant than traveling by road, on rails, or in the air." The Transrapid 07 is even faster and more comfortable. The new, more highly developed proving vehicle is designed for a top speed of 500 kilometers an hour. Before Transrapid 07 starts its endurance trials on the TVE, it is presented to the public for the first time at the 1988 International Transportation Exhibition in Hamburg. After years of trials under service conditions in continuous operation on the test track and intensive testing and assessment, experts from the Federal Railways and leading university institutes agree in 1991 that the maglev system is ready for public service. No other railway system has ever been subjected to such intense scrutiny as the Transrapid. Thus, an important precondition for introduction of the Transrapid system has been fulfilled. First, however, Transrapid 07 shows what it is capable of. Under normal operating conditions on June 17, 1993, it hovers over the test track, reaching a top speed of 450 kilometers an hour, a new world speed record for maglev railways. The configuration of the test track means that the maximum design speed is just out of reach. In 1994, the federal government decides that a Transrapid track shall be laid between Berlin and Hamburg. The maglev trains would cover the distance of approximately 300 kilometers between the 2 largest German metropolises in less than an hour. Planning and authorization work proceeds apace. Nevertheless, the decision is taken in the year 2000 to discontinue the project. Original forecasts of traffic to be expected on this axis no longer appear realistic in view of the modest economic development both in Eastern Germany and in Europe generally. Alternative possibilities are therefore investigated for use of the Transrapid within Germany. Right from the beginning, Siemens and ThyssenKrupp have been the companies behind decisive moves in development and testing maglev technology in Germany. For worldwide introduction of the Transrapid system, the two companies now pool their experience and their know-how in the formation of Transrapid International. As the company is founded in Berlin in 1998, in addition to other representatives from the worlds of politics and economics, one of the participants is the man who, in 1969, fired the starting pistol for development of the innovative railway technology, the then Federal Minister of Transport, Georg Leber. Development continues. Transrapid 08 is now undergoing trials on the TVE. During the World Exhibition, Expo 2000, the first prototype of a production series carries passengers from all over the world around the Emsland test track in scheduled operations. Transrapid 08 is a 3-section unit and is designed for a maximum speed of 500 kilometers an hour. The international breakthrough for the non-contact railway technology. The city of Shanghai and Transrapid International agreed to carry out a study into the feasibility of a Transrapid connection from the center of the Chinese metropolis to the new Pudong International Airport. On the occasion of the visit of the Chinese Prime Minister Zhu Rongji to Berlin, a corresponding agreement is signed in the presence of the Federal Chancellor Gerhard Schröder. The Chinese head of state convinces himself personally of the benefits of the new railway technology on a trip with the Transrapid 08 on the Emsland test track. Shanghai, early in 2001. Construction of the Transrapid track between the center of the 14 million strong city and the airport Pudong International gets underway. The maglev train will only take 8 minutes to cover the distance of approximately 30 kilometers.
Ich glaube, jetzt erfolgt ein historischer Moment.
Former Federal Minister of Transport Kurt Bodewig sends the maglev train off on its long journey to China.
Schwebt, wird erfolgreich schweben.
Previously, in January 2002 in Berlin, the Federal Minister of Transport had presented the results of feasibility studies on 2 applications for the Transrapid in Bavaria and North Rhine-Westphalia. Preparations are currently being made to start work on the line in Bavaria. In just a few years, the maglev railway system will connect Munich with Franz Josef Strauss Airport. Today, the journey time from the center of the Bavarian metropolis to the airport by rapid transit train is around 45 minutes. By car, it is often even longer. The Transrapid will cut the journey time for the 37-kilometer trip to a mere 10 minutes. The train to the plane will then leave Munich main station 6 times an hour. On New Year's Eve 2002, the world's first commercial Transrapid superspeed maglev train started for its maiden trip in Shanghai and opened a new chapter of railroad history. Presence of German Chancellor Gerhard Schröder and Chinese Prime Minister Zhu Rongji on board the train, the Transrapid reached the operating speed of 430 kilometers per hour, planned for scheduled operation on the 30-kilometer-long route between the city center and Pudong International Airport. The induction suspension railway is the technology for the 21st century. It provides a fast, economical connection between metropolis and airport. As an environmentally acceptable high-performance transport system, the Transrapid brings traffic relief to major centers and conurbations. And over long distances, journey times by maglev train are as short as today's air journey times. This is why there is a change of course being made towards the non-contact railway technology made in Germany.